Welcome to part 2 in our series of videos on ICP OES, Inductively Coupled Plasma Optical Emission Spectroscopy. In the first video, we looked at the instrument itself and the components that are important to its operation. In this video, we will be focusing on the operation of the instrument itself in terms of collecting data. There are 3 main objectives in this section. First, we'll look at how we can prepare the instrument for startup, and then we will look at the startup procedure itself. Once we have completed that, we will start talking about how we can carry out a routine operation of the ICP spectrometer. In other words, we will look at the actual procedures for creating a calibration curve, blanking the instrument, and then, of course, collecting data. Now, the first thing that needs to be done with this instrument before we can even think about starting it up is to ensure that we have proper ventilation. So make sure that you turn off the ventilation to the atomic absorption spectrometer and turn on the ventilation to the ICP spectrometer. This can be done by pulling the levers on the fume hoods such that the lever is pointing straight down for the instrument that you want to have active ventilation and is pointing straight to the left or right for the instrument that you do not want ventilated. Once we have secured proper ventilation for the ICP system, the next step is to turn on all the appropriate gases. For ICP, we will be using 2 different types of gas. We will be using argon and compressed air. Now, the argon is going to be supplied using a large liquid argon tank. And as you can see, this tank is much more complicated than the one that you are used to for the AA. In other words, the acetylene tank. This particular tank has several different ports on the top. The only one that we're going to concern ourselves with right now is the one that leads to the regulator on the left-hand side. By turning on the green valve connected to that regulator, we will be supplying sufficient argon gas to the instrument. Once the argon source has been turned on, the next step is to make sure that the compressed air has been turned on. For information on how to turn on the compressed air, please see the video on atomic absorption spectroscopy. It is important to note that both the compressed air and the argon need to be pressurized within the parameters that have been set for the ICP instrument. These parameters can be found on the sign on the wall next to the instrument. Once the gases have been started up and the ventilation has been turned on, the next task for us is to turn on the actual spectrometer, and this is accomplished by turning on the on switch on the right side of the instrument. Please note that this switch needs to be clicked over completely. If you push it too gently, you will not turn the instrument on. So please make sure that you push the switch over all the way. And that's about all that needs to be done to start the instrument up. With the instrument started, we can now turn our attention to the software that's required for running the instrument. So on the computer, you will find an icon on the desktop called WinLab. By double-clicking on that icon, you will open up the software. Upon starting the WinLab software, you'll see a startup screen, as is shown in this image right here. There are 2 boxes that indicate status of the instrument itself. If the instrument has been completely turned on prior to opening up the software, the checkboxes should show up green. If you get an error message, simply close down the software and restart it after the instrument has had enough time to start up completely. At the completion of startup, you will notice that a workspace is opened up onto the computer screen. Now, this workspace does look very complicated at first glance. There are many different buttons and many different functions. Fortunately, there's only a handful of these that we actually need to use in order to collect data. One of the most important parts here is going to be the method box, which can be found on the top middle to right hand side of the computer screen. By clicking on the method button, we can actually edit the method. In other words, it allows us to select a metal wavelength read delay, and all sorts of different things like that. The next button I would like to call your attention to is the plasma button. By pushing this button, you will gain control over the startup of the plasma in the ICP spectrometer. This will also allow you to monitor the levels of the different gases coming into the instrument. The next box that I would like you to pay attention to is the manual box. By clicking on this box, you will open up an interface that allows you to collect samples and to enter sample names, blank the instrument, enter standards, all of that. The last button we will be looking at is the results button. And by clicking on the results button, we open up a text-based screen where you will find all the data that you collect during your analysis. As noted earlier, by clicking on the plasma button, we bring up a screen that allows us to control the plasma itself. The screen contains a on-off switch that will turn the plasma on and off, among many other different types of gauges. Of all the things that are on this screen, the one that is most important next to the on-off switch is the control of the peristaltic pumps for sample delivery to the system. By clicking on the button labeled Manual, we will bring up a window that allows us to enter the identities of our samples, to run blanks on the instrument, to run samples, and to run standards. Now, for the purpose of our classes, we will not be running any standards. We will run our standards as if they were samples. The reason for this is that the instrument comes equipped with some really fancy tools that will create a calibration curve for you and do your calculations for you. But being that this is your first course using an ICP, you are responsible for computing your own calibration curves using Excel. By clicking on the Method button, we'll bring up a screen that will allow us to select the method that we want to use for our particular experiment. Our instrument is already equipped with several different methods for several different elements. However, if you need to analyze for an element other than the one you see here, you would simply click on the New Method button. For now, you'll just be using the methods that are found on the instrument already, so select the one that the instructor has indicated for this experiment and press the OK button to complete the selection of the method. With the method selected, it's now time to turn on the plasma. And as stated earlier, this is done by pressing the virtual on switch on the computer screen in the window that's brought up by pressing the plasma control button. You will notice that upon pushing that button, the instrument will start undergoing some different sounds. It's important that you do not be alarmed by these sounds. You'll also notice that there's going to be a considerable delay between the point where you press the switch and the point where the torch actually starts up. Again, you should not be alarmed by this. If you find that the torch does not ignite on the first try, do not be alarmed either. Allow 2 or 3 times for the instrument to ignite the torch before consulting with the instructor. You will know that you have successfully ignited the plasma on the instrument when you look through the viewing window and see a light green flame-like shape inside of the viewing area. It is recommended that upon igniting the plasma for this instrument, that you allow it at least a half hour to an hour to warm up before completing any type of analysis. Once the instrument has warmed up sufficiently, you can press the green manual button to open up the screen that allows you to control the instrument itself. The first thing you want to do is to place the sipper straw of the ICP into your blank solution. Typically this will be distilled water or distilled water with a little bit of nitric acid in it. And you're going to press the Analyze Blank button. And basically what this does is tell the instrument that this is what nothing looks like. Now, after you have blanked the instrument, you can then use the Analyze Sample button to analyze both your samples and your standards. I highly recommend that you enter a sample name in for each one of the samples that you introduce into the instrument to aid you in being able to decipher which data belongs to which sample after the analysis has been completed. In the process of analyzing samples, you may notice that the instrument takes a little bit longer than it typically does to collect the data for an individual replicate for that sample. Typically, this is due to some kind of a problem with the sample introduction system. In other words, the instrument has not seen an even intensity of light being produced by your sample. When this happens, you should consult with your instructor to look for different problems that may be causing this issue. When the analysis is complete, you can open up the results window by pressing the results button on the main workspace. This will open up a text-based document that will contain all of the data and information about your experiment. The data that is probably of most importance to you will be the corrected intensity, the average corrected intensity for your specific sample. This is the number that you should use as the value when creating a calibration curve or when converting an intensity to a concentration. The values on this table can be printed out or they can be saved to a flash drive. Either way, you can remove the data from this computer and take it with you so that you can analyze it further. I would also like to point out that the information that is on your data sheets can also be used to determine whether or not the instrument is operating properly. For instance, you can look at the magnitude of the values of your samples, and if they tend to be very, very low, when you know that your concentration of analyte is very high, this is a pretty good indication that the sample introduction system may be blocked up, or possibly you've made your samples incorrectly. You may also notice that you will receive a error message that says saturated, which would be an indication that your concentrations are much too high for the instrument. You may see a great deal of variations within the replicates of a given solution. This too is an indication that there may be problems with the sample introduction system. The pump may not be working properly, there may be a clog, etc. Well, that pretty much wraps up everything that you need to know in order to start up the ICP instrument and to run a very basic analysis. There are some other subtle nuances and important details that will make your usage of this instrument more effective and more efficient. As always, I recommend that you take the time to meet with your instructor to discuss some of the finer details of this instrument, and of course to make sure that you take the time to practice using this instrument as well, so that you can be successful in your practical exams and in your future careers. Thank you for taking the time to watch this video.